video in the series Bridging the Gap from equations of straight lines to integral calculus. In this video I just want to quickly summarise some of the things we've learned and then we'll walk through the answers to all of the questions at the end of all of the previous videos. Okay, so what have we learned? Well, we've learned that the equation of a straight line is y equals mx plus c, where the slope is the change in y divided by the change in x. And the y-intercept can be found just by taking any point on the line and substituting that into the equation. We've learned that when we have a line that isn't straight, let's see if I can draw a line that's not straight. What we can do is take a secant line where we find any 2 points on that line, and we can draw a straight line between that secant line, or between those points, to create a secant line, and then we can look for the slope of that secant line. And we've learned that the closer those 2 points get together, the closer the secant line comes to a tangent line, which is a line that just touches the curve at exactly 1 point. And the slope of that tangent line is the slope of the curve at that precise point. We've also learned that we can take limits to essentially plug the gap of undefined functions. So if we have something like 0 divided by 0, the limit may not be able to be determined. We can call that the indeterminate form. But we know that 0 over 0 is undefined. But the limit as x approaches 0 of x over x is 1. And in the same way, the limit as x approaches 0 of 2x over x is 2. And 3x over x is 3. And ax over x is a. We've also learned that if we have a function in the form of f of x, I'm jumping the gun, f of x equals ax to the power n, then the slope of that curve is anx to the power n minus 1, and that slope is the derivative. Or rather, the derivative is a function that gives us the slope at any particular point. And we've learned that there are ways that we can find the derivative of more complicated expressions or equations, such as the chain rule, the product rule, and the quotient rule. We've looked at, or we've seen that trigonometric functions can have derivatives as well. We haven't actually proved it, but we've shown that the derivative of sine x, or not shown, but we've seen that the derivative of sine x with respect to x is equal to cos x, and things like that. And even the most fun one, I think, is the derivative of e to the power x with respect to x is equal to e to the power x, which I absolutely love. And we've learned that we can go backwards, that the antiderivative is the indefinite integral. And we've learned that we can get the area under the slope by taking the definite integral Oh, I should have said that the indefinite integral is f of x plus c. Forgot to say that. And the definite integral and that's pretty much what we've covered. Okay, I hope that was helpful. Okay, so let's go and have a look at the answers to the questions we set in the video. Okay, at the end of lesson 1 I left you with find the equation of a straight line passing through these 2 points, 4, 5 and 6, 11. Okay, so we know that y equals mx plus c. And we know that m is equal to delta y by delta x. Now let's have a look. So delta y is equal to, well, it's going from 5 to 11, so that's 11 minus 5, and that's equal to 6. And now delta x is equal to, so it's 6 minus 4, because it's going from 4 to 6. So that's 6 minus 4. And that's equal to 2. So delta y divided by delta x is equal, actually I better write that down, delta y over delta x is equal to 6 over 2, which is equal to 3. So y is equal to 3x plus c. Now, what is c? Well, let's plug 4, 5 in, why not? So 5 is equal to 3 times 4, because x is equal to 4 and y is equal to 5, and that's plus c. So 5 is equal to 12 plus c. So 5 minus 12 is equal to c. So 5 plus 7 equals 12. So this is negative 7 is equal to c. Right then, so that gives us y equals 3x minus 7, which is the equation of the line passing through those 2 points. And that's our answer to question 1. Okay, so question 2 says f of x equals 5x plus 3, g of x equals x squared, and h of x equals 1 over x. What is f of 3? Okay, so f of 3 is equal to 5 times 3 plus 3. which is equal to 15 plus 3, which is equal to 18. Oh dear, my 8 is terrible, isn't it? Looks like a fancy G. Okay, let's try and draw that properly. Okay, so that's f of 3, because we know what f is, because f is defined here as 5x plus 3. And we know the value of x because it's the number that's inside the brackets here. So we're just taking this 5x plus 3, and where we see x, we're substituting in 3. So we do the same for g of 2. So g of 2. This time g is defined as x squared, and x equals 2 because 2 is in the brackets. So g of x is equal to 2 squared, which is equal to 4. And lastly, what is h of 4? Well, h is 1 over x, and it's h of 4, so this is 1 over 4. And now we've got some nested functions here. So we've got what is f of g of x. Alright, so f is 5 times x plus 3. But we know x is g of x, so that's 5 times g of x plus 3. And g of x is x squared, so we can replace g of x for x squared. And that is our final answer. So f of g of x is equal to 5x squared plus 3. Okay, so what is f of h of x? Okay, so f is 5x plus 3. Actually, I'm going to write this here. F of h of x is equal to, so this is a 5x plus 3, and we're replacing x with h of x. So that's 5 times h of x plus 3. And h of x is 1 over x. So that's 5 times one over x plus 3. Well, 5 times 1 over x is just 5 over x. So that's 5 over x. And that's a terrible x. And then that's plus 3. Okay, so that's f of h of x. Okay, so what about h of f of x? So h of f of x well, what is h of x? H of x is defined as 1 over x, So this is 1 over f of x, and f of x is 5x plus 3. So we can replace f of x with 5x plus 3. That's h of f of x. And g of h of f of x, okay. Well, we already know what h of f of x is, so we just know that that's 1 over 5x plus 3. And g is just x squared, so g of h of f of x is equal to, so that's g of 1 over 5x plus 3, because we just figured out what h of f of x is. And g of x is defined as x squared, so we can get rid of the g. And just say that it's all of this squared. And that's our answer to part 2, or all of the answers to part 2. Okay, so question 3, or the question at the end of lesson 3, was a curve is defined by the equation f of x equals 3x cubed. Estimate the slope of the curve at 2, 24. Okay. So what we want to do is to find a tangent line by getting a secant line that gets ever closer and closer together. So let's pick 2 points on a secant line that's close to 2, 24. Shall we try x equals 1.9 and x equals 2.1. That should be pretty close to get a an estimate of the slope of the curve. I mean, now that we've gone through all of the questions, we could find the answer very quickly by getting the derivative. So 3 times 3 is 9 times x squared, and that is at x equals 2, so that's 9 times 2 squared, which is 9 times 4, which is 36. So we actually know that the correct answer is 36, but we're going to go through with the tools that we had when we'd finished lessons 3. So at 1.9, y would be 3 times 1.9 cubed, and 3 times 2.1 cubed, and that would be our y. Alright, so I think we're going to want a calculator for this. Okay, so 3 times 1.9 raised to the power 3 is equal to 20.577. times 2.1 to the power 3 is equal to 27.783. Okay, so our slope is delta y by delta x. So that's equal to 27.783 minus 20.577, all divided by 2.1 minus 1.9. .783 minus 20.577 divided by 2.1 minus 1.9 equals 36.03, which I think you'll agree is very close to the actual true slope, which is 36. Okay, so question 4 reads, what is the limit of x squared minus x minus 6 over x plus 2 as x approaches negative 2? Okay, well, let's have a look. Right, so we can say for certain that x does not equal negative 2, so we can't just plug negative 2 in and get our answer. So we're going to have to approximate, so we can simplify this algebraic fraction. So x squared minus x, oh dear, minus x minus 6 is equal to, so we need to factorize this, so we're looking for two numbers that add together to give negative 1 and multiply together to give negative 6. So the signs must be different, and the negative number must be the larger number. So we've got the factors of 6 are 3 and 2, which are 1 apart. So we're going to have x minus 3 into x plus 2. Now then, and of course we've got x plus 2 on the bottom. Cancel, cancel, because we know x is not going to be 2, but we're looking for the limit as x equals 2. So our curve x minus 3, or rather y equals x minus 3, is the straight line, which can also be called a curve, believe it or not, that will give us our estimation of where y should be at x equals minus 2. So when x equals minus 2, then we have negative 2 minus 3 is negative 5. So the limit as x approaches negative 2 of basically this equals negative 5. That was convenient. And that is our answer. Okay, the question at the end of lesson 5 read, what is the slope of the curve y equals x squared at point x comma y? So here we are looking for the first derivative. So the derivative dy by dx, and we know y is equal to x squared, so we're taking the 2 across, so the 2 comes down and then we're subtracting 1, so that's just 2x, or 2x to the power 1. Okay, the lesson 6 ended with the question, find the derivative of f of x equals 2x cubed plus 3x squared plus 9x plus 7. Okay, well that's fairly straightforward. We know that the sum of the derivative is equal to the derivative of the sum, so we can take the derivative of every point. So f prime of x is equal to 3 times 2 is 6, so that's 6x squared because the index comes down by 1, plus 3 times, or 2 times 3 is 6, and that's x, and then x squared becomes x to the power 1, which is just x, plus 9x, well that's just 9, and then the 7 disappears, and that's our final answer. Okay, so question 7 says, consider the curve y equals 1/3 x cubed plus 1/2 x squared plus 6x, minus 6x plus 2. I can already see that minus is going to cause me trouble. Okay, so find the points on the curve where the slope is exactly 0. Okay, so the first thing we need to do is to find the slope of the curve. So dy by dx. Oh, that's terrible. What kind of writing do you call that? Dy by dx is equal to, okay, so 3 times 1/3 is 3 over 3, which is 1. So that's just x, and the 3 becomes a 2, so that's x squared plus 1/2 times x squared. Well, again, 2 times 1/2 is just 1, so that's just x. And then minus 6x, so that just becomes minus 6. So x squared plus x minus 6. Now, we want the points on the curve where the slope is exactly 0. So it's exactly 0 when dy by dx equals 0, because dy by dx is the slope of the curve. So 0 equals x squared plus x minus 6. So we've got a straightforward quadratic equation here. We're looking for two numbers, and the two numbers multiply together to give -6 and add together to give 1. So again, we're looking at 3 and 2, aren't we? They've got to be opposite signs, but this time the bigger number needs to be positive because the x term is positive. There's my cursor. Okay, so we're looking at 0 is equal to x plus 3, x minus 2. Alright, so that x is not very good, is it? That's close enough. Okay. So either x is -3, because -3 plus 3 is 0 and 0 times anything is 0, or x is 2, because 2 minus 2 is 0 and 0 times anything is 0. So x equals -3 or x equals 2. Now we need the points. So when x equals -3, then 1/3 x cubed, so it's 1/3 times -3 cubed plus 1/2 x squared minus 6, so that's minus 6 times -3 plus 2. Okay, so that is equal to, well, 1/3 times -3 cubed is -27/3 plus -3 squared is 9, so that's 9/2 minus 6 times -3, so that's minus -18, which is the same as plus 18. I'm not going to write down plus 18 because the next term is plus 2 and 18 plus 2 is 20. Okay, so -27 divided by 3 is -9. So that's equal to -9 plus 4.5 plus 20. 20 minus 9, well, 20 minus 10 is 10, so 20 minus 9 would be 11, so this is equal to 11 plus 4.5. Oh, this is not good at all. Okay. So 4.5, 11 plus 4.5, which is equal to 15.5. So I'm now going to remove this working because we've done the working. So one of the points is -3, 15.5, and now we've also got x equals 2. So at x equals 2, we have 1/3 times 2 cubed plus 1/2 times 2 squared plus, nope, minus minus 6 times 2, which is just 12, and then plus 2. Okay, well, minus 12 plus 2 is minus 10. So I'm going to take that and say that's minus 10. Two cubed is 8, so that's 8 over 3. 1 over 3 times 8 is 8 over 3. Plus 1/2 times 2 squared, well, that's just 2. 2 times 2 divided by 2, yeah, that's 2. And then minus 10. So 2 minus 10 is negative 8. Okay, so eight over 3 minus 8. Well, 8 times 3 is 24. So that's 24 over 3. That's 8 times 3 divided by 3 is 8. 24 over 3. So 8 minus 24, well, that's negative 16 over 3. Okay. So our answers are: the slope is exactly 0 at negative 3 comma 15.5 and 2 comma negative 16 over 3. Should I make that a decimal? Why not? Let's make that a decimal. So negative 16 over 3, 4 times 3 is 12, 5 times 3 is 6, so that's negative 5 and 1/3, so that's negative 5.333 recurring. So it's negative 5.333. And as you can see, these are the local maximum and minimum points on the curve. These are the points where the slope is exactly 0, and we can prove that by simply writing in y equals minus 5.333. Well, we can use this line that goes up and down to prove that the tangent is indeed 0. The tangent line, the slope of the tangent line is indeed 0 at that point. And if we move it all the way up, no, we can't move it all the way up. Okay, so let's say y is equal to 15.5. And again, you can see the slope of the tangent line is indeed 0. Okay, so question 8 is asking, if y is equal to 1 over the square root of 2x squared plus 6, find dy by dx. Well, that just screams chain rule, doesn't it? Let's say u is equal to 2x squared plus 6. Now 1 over the square root of 2x squared plus 6 is 2x squared plus 6 raised to the power of negative 1 over 2, because 1 over 2 is the square root and negative is 1 over. So y is equal to u raised to the power negative a half. Okay, so we remember that dy by dx is equal to dy by du times du by dx. So dy by dx is dy by du, so dy by du is equal to negative 1/2 u raised to the power of negative 3 over 2, because 1/2 minus 1 is, sorry, negative a half minus 1 would be negative a half minus 2 over 2, which is negative 3 over 2. I want to make that look a bit more like a 2 so I don't get confused. Okay, that's dy by dx. So it's dy by du times, and du by dx is going to be 2 times 2, which is 4x to the power 1 plus, and the plus 6 is going to disappear. And now we need to express u in terms of x. So u is equal to 2x squared plus 6. And then that's raised to the power of negative 3 over 2. And all that is multiplied by 4x. We could simplify that if we want, but that is actually the answer. Okay, so picking up in question 9, it says find the derivative of y to the power 7 plus 2y cubed equals 9x cubed plus 5x squared with respect to x. Well, that would be really difficult to do explicitly, so this just screams implicit differentiation, doesn't it? Okay, so we can say that the derivative of y to the power 7 plus 2y cubed with respect to x, which of course we could have also said the derivative of y to the power 7 plus the derivative of y cubed. In fact, we probably could do that just to show that it's definitely possible to do. Plus the derivative with respect to x. Remember, the sum of the derivative is equal to the derivative of the sums, is equal to the derivative of 9x cubed with respect to x plus the derivative of 5x squared with respect to x. Okay, so the derivative of y to the power 7 with respect to x, remember y changes with respect to x, so it's not a constant. So we have 7y to the power 6, and by the chain rule that also has to be multiplied by dy by dx. It's just like if we'd done a substitution. And then that's plus, by the same reasoning, we have 3y squared dy by dx. And that's all equal to, well, this time it's d of some function of x with respect to x, so that's just 3 times 9 is 27x squared. So there's no need to multiply by dy by dx. And then 2 times 5 is 10, so that's 10x to the power 1. Okay, factor out the dy by dx. That should be a y by dx into 7y to the power 6 plus 3y squared, and that's equal to, well, all of that. And lastly, we just divide by the stuff that's in the brackets. I'm going to get rid of the brackets. And that is our final answer. Okay, so the question at the end of lesson 10 read, what is the indefinite integral of x cubed plus 9x squared plus 2x plus 3 with respect to x? Okay, so that's, so we can write down the x cubed, or rather we can write down the x. The 3 increases by 1, so it becomes a 4, and then we have to divide by 4. Or we could multiply by 1 over 4. And then we add, now we've got 9x. Now the 2 becomes a 3, and we divide by 3. Well, 9 over 3 is just 3. Let me just tidy this up a little bit. There we go, plus. Now we're looking at the 2x. Well, we know that the integral of 2x with respect to x is x squared. We know that by now. Come on. And then that 3 just becomes 3x. And the important thing that we must never forget is plus c. And that is our final answer. And our final question, the question at the end of the last lesson, was to find the area under the curve of y equals 3x squared plus 2x plus 1 between x equals 0 and x equals 2. Well, that's just the definite integral between 0 and 2 of 3x squared plus 2x plus 1 with respect to x. Okay, so let's just find the indefinite integral. The indefinite integral of 3x squared plus 2x plus 1 with respect to x. That's a terrible x, isn't it? Okay, so that is going to be so 3x squared. We increase the 2 by 1 to get a 3 and bring down 3 and divide by the 3. So 3 over 3 is 1, so that's just x cubed plus 2x is just x squared, isn't it? Yeah, or rather, the integral of 2x with respect to x is just x squared plus c. And then we add, then there's a plus 1, so the integral of plus 1 is going to, with respect to x, is x. And then the whole thing is plus c. Or you add c to everything. Well, we know the plus c's are going to cancel out, so we can get rid of the plus c. And then we can start plugging in our numbers. So the 2, so we've got 2 cubed plus 2 squared plus 2 and then we're subtracting 0 cubed plus 0 squared plus 0, which is just going to be 0. So we're subtracting 0, and we know that if you subtract 0, nothing changes. So this is equal to 2 cubed is 8, 2 squared is 4, and then we've got 2. So it's 8 plus 4 plus 2. Well, 8 plus 2 is 10. 10 plus 4 is 14. That's 14 units under the curve y equals 3x squared plus 2x plus 1 between x equals 0 and x equals 2. And that's our final answer. Okay, I hope you've enjoyed these lessons, and I hope now you've got a lot of confidence with regards to calculus. If you want to show off to your friends, you can say that you've been studying differential and integral calculus, but if your friends already know what differential and integral calculus are, then they will be considerably less impressed, because it's nowhere near as hard as it sounds. Okay, I hope you've enjoyed this, and I hope to see you in some future video. If you want me to make more videos, just please leave comments as to what you'd be interested in learning. If you want to know where to go from here, I think the next logical step from what we've covered would probably be differential equations. Okay, take care of yourself, and I'll hopefully see you in another video.